There we go. Now, what this does is, I know you can't see me, but I don't care. This is going to shoot the ball this way, horizontally, and this ball is going to be released. Everybody needs to stand up. You need to get over here and look at what I've got here. And what I need is, I need two witnesses. I want you down kind of squatting, looking at the ground, and I want you to tell me what you hear. And this is not going to shoot over there. It's basically what's going to end up happening is it's going to shoot horizontally. Now, here's the deal. I'm proposing to you that if you shoot something horizontally and you drop something, boom, and you drop them, they will hit the ground at the same time. All right? If that is true, here's what I should hear. When these things hit the ground, if they hit the ground at the same time, I should hear this. If not, it'll be something like that. Everybody understands? And we'll do this a couple times. And I'll do 1, 2, 3, or 3, or 1, 2, 3, and I'll pull the trigger here. All right, so here we go. 1, 2, 3. Well, crap, did you hear that? What did you hear? What did they do? They did what? What did they do? One shot horizontally, one shot at the same time. What did you observe?
I heard the patter of at least the bouncing afterwards, and then I couldn't tell when that one went.
Okay, why don't you stand over here? You get over here and look this way. And even listen. And actually, go at the corner here. Go at the corner because you'll see this way, okay? And if you can, and here's the deal. Watch what happens. Ready? 1, 2, 3. Did you hear it? Did they hit the ground at the same time? You didn't think they hit the ground at the same time? Let's try it again. Get my marble, or my steel dude here. One more time. Let's try this. It's going to hit you in the foot. You may want to move over here. I'm going to try to. Ready? 1, 2, 3. They hit the ground at the same time. Holy crap. Isn't that cool? At the same time. Now we're neglecting air resistance now. So here's what happens. I shoot a gun horizontally, I drop something. How about this? I have a high-powered rifle. The fastest rifle out there, fastest bullet. And I shoot it horizontally. You know how long it's going to be in the air? Boom! It will hit the ground. Now you think, I had a friend one time. But Mike, he was in the military, I was telling him about it when I was in college. I was in physics class. He said, no, Mike, that's not true because I remember being in the military, I'd shoot and the bullet was in the air for several seconds. No, Larry, that's not true. No, I said, Larry, you had to be shooting it up in the air. Now, if you're shooting it up in the air, that's a different story. We're talking about horizontally. But here, if you're shooting a high-powered gun, any type of gun, or even a little BB gun, or a little dart gun, you know what? This height, horizontally, it will stay in the air no longer than this. Just a split second.
Well, if you're saying real world, then like your friend, wouldn't he not be disconcerting air resistance? And doesn't like the shape of the bullet keep it up a bit longer?
Yeah, that's a different baby altogether. We don't even go there.
Well, I was talking about you told your friend that it would only be as long as that when the air resistance holds up.
No, air resistance would slow it down, but it won't make that considerable of a difference in the air.
Okay.
So let me think. So some would say, well, wait a second. Wouldn't a BB gun and a high-powered rifle? Wouldn't a high-powered rifle? No. What will happen is, after let's say a quarter of a second, they'll still be at the same height, but the high-powered rifle will be what? Further down the road. So by the time they both hit the ground at the same time. So here's what we've got. We've got somebody with a little Nerf gun, then a BB gun, then a pistol, then a high-powered rifle. They shoot all at the same time. They all hit the ground same time. But where's the high-powered rifle? It traveled way farther versus the Nerf gun shorter, but they hit the ground at the same time. Now again, we're neglecting air resistance. That's something we're not going to deal with, address with. That is a different baby. We don't even deal with that in AP2. We started messing with it back in fluids my junior year in physics, and it's really, it's a very sorted, you know, if you're getting into, you know, military, if you're like higher up, yeah, those are things you deal with, but for now, this is what we're dealing with, okay? So this is really interesting, all right? So, how does this work? Let me give you an example. Let me find my marker here. So here's what's happening. I want you to catch this. Let's suppose I'm on the edge of a cliff and I shoot something. And I shoot it at 30 meters per second. I want you to see something here. Gravity only acts which direction? In this way. Everybody catching that? Only in this direction. So here's the deal. Let's see what this looks like. All right, that's kind of what it looks like. Do you know after 1 second, you know how fast it's going? Let me make this a little bit longer. Guess what? It's going 30 meters per second. Because gravity only affects what? The y direction. Now really focus, folks. We were dealing with an x and a y direction here. Do you know 2 seconds later? It's going 30 meters per second in the horizontal direction. 3 seconds later, 30 meters per second. 4 seconds later. But what's acceleration? In the y direction. After the first second, it's doing what? 9.8 meters per second. After 2 seconds, it's what? 19.6, right? After, let's do 19.6. What's after, then what? 29.4? 29.4 meters per second. What's happening now? What's 4 times 9.8? 39.2? 39.2. Then right down here, it's got 30 meters per second, and then it's like that. What you have projectile motion is parabolic in nature, all right? Everybody sees what we did there. What happens is, I want you to think, what is the simplest parabolic equation? Y equals x squared. It is the simplest of all. If you think about it, if I plug in 0, 1, 2, 3, 4, because I see patterns. Physics, I like physics as patterns. It just makes sense, all right? So if you think about projectile, forget it. Hold on. I'm gonna put another picture here. Let's suppose I kick something at an angle. You're in soccer, all right? And watch what happens. Let me see if, hey Kylie, would you go next door and see if Mrs. Thomas is in there? And if she is, ask her if we can get a football or a basket. Actually, get a football.
A football?
Football, I appreciate it. Now I want you to see something. I kick a ball at an angle. Again, we're all neglecting air resistance, all right? You know what? It has a vertical and a horizontal component to it. The horizontal component, guess what? What can we say about the horizontal component?
It's the same.
It's constant. But you know what happens to the vertical component? Less, nothing, and then what happens?
More.
Yeah. All right, obviously Miss Thomas wasn't there. Kyler will go pick this up. Now, by the way, this horizontal component is the same as this. What can we say about this vertical component and this vertical component?
They're opposites.
They're opposite. Are they the same magnitude? Darn tootin'. All right? What did I say if I throw something up in the air and then I catch it?
Same.
It's the same velocity. All right? All right. Come on, Kylie. I'm in
Most
chapter
might not
3,
have
so
a
let me turn
football
chapter 3.
fan,
Huh?
but you might not have a football just sitting there.
Ah, that is true. I figured she'd chase her down normally I forgot to get the ball this morning. I knew we were doing projectile motion. All right. So this is just downright cool here because, I mean, all of you. Now, Maggie, what sport are you in?
Oh, I don't know.
Oh, I thought you were a sport. What are you a soccer?
Yeah.
Okay.
Soccer,
Aren't all the
soccer,
Goals
soccer.
clan? The Goals clan, aren't you guys all, your sisters were soccer? Like you're like aren't you the last boy? The only boy?
Yep.
Only boy, the last one in the last Goals, right? All right. Yeah, I thought they were all soccer.
Yeah.
The girls were all soccer. All right. So here's the deal. If you're in a sport, now I want you to think about this. You're in football, projectile motion. Volleyball, projectile motion. Volleyball, basketball, football, all those sports. All right? There's think about this. Oh, I'll let her in.
So there were no teachers?
That'll work.
Oh, yeah, I got that.
Will work. Where'd you take it from?
The gym.
Oh, did you tell them?
No.
They didn't know I saw you, did they?
It was like an open.
Did anybody see you?
No.
Good.
I mean,
All
it was
right.
like-
Nobody saw us.
Dawn says a new vlog.
Yeah. All right. Listen, possession is 9/10 of the law, and there's nobody's name on this. All right. So it's mine. Finders keepers. All right. So here's the deal. Most of you are, and I would say all of you. Were you in a sport at one time?
Yeah.
What?
Cross country and track.
Okay. Track. You're running. So and what? You're actually. Do you ever do hurdles, stuff like that? Okay. So you are kind of when you're running, you are kind of a projectile when you run over it. All right.
Oh, yeah.
So those are all sports, and you look, most all sports, there's projectile in them, all right? And so, any cheerleaders here? Okay, good, because that's not a sport, just so you know. There's no projectile motion.
What
So it's
about
not a
when
sport.
They throw the girls in the air.
Yeah, that could be, and they fall to the ground. There's physics. Hey, I've seen a few of them crash. Now, I think they don't allow them to go over 2 or something like that. There's a law now, they don't allow them to go 3 high or something like that. But that's scary. All right, so most every sport, all right? Just make sure I have, okay, mobility here. Okay, send her back. Watch my camera. There we go.
We're still passing it around, I'm sorry.
You have her name, right? All right. Now, so understand this thing called projectile motion, right? So here's the deal. Kylie, what I said was, if we kick like a football, your horizontal component remains the same. It's your vertical that changes. Like, you got a vertical velocity, it gets less, 0, and then, so what is the acceleration at the top?
-9.8 meters per second.
Okay. I tried to stump you. All right. I was wanting somebody to say what?
0.
Is it 0?
No.
Velocity.
Because if any of your life, gravity is 0, you're in trouble, okay? Gravity has always been 9.8 your whole life, okay? Now, like I said, you see a lot of things. Oh, here's something to think about. We said first of all, notice how we see the objects seem to be parabolic in nature. We see parabolic in nature. Okay, so here's the deal. I want you to catch what I'm doing here. So they're parabolic in nature, and so we said that the simplest parabola is what? Y equals x squared, right? Now, if you'll notice what is happening on these, one direction stays constant, the other one increases. It increases, right? Well, think about a parabola. What happens? One stays constant, and what happens? One side stays constant. Or I should actually say this. Hold on. Let me think about this. How I'm going with this. Y equals x squared You put 0 in, 0. 1 in, what do you get? 1. 2 in, you get 4. 3 in, 9, 4, 4, 16, right? So here's the deal. If you take a look here, if I wanted to compare distances traveled, in the horizontal distance, horizontal direction, the distance traveled every second is going to be constant, all right? But in the vertical direction, what's the initial velocity in the y direction? If I shoot something horizontally, what's the initial velocity in the y direction? 0. So guess what you have? What equation dictates the distance traveled? D is equal to 1/2, or let's say this, D is equal to 4.9 t squared. Parabolic, right? So as you go 1 second over, it increases exponentially down the distance. All right? Does that make sense? So the same there, that's basically projectile motion is, and if you can remember this idea, it will make everything easier. In the x direction, it stays constant. In the y direction, it increases. Okay, got it? Okay, hold on now. All right, so let's make up one. Let's make up one. Let's suppose I'm on the edge of a cliff and I throw something horizontally. And I shoot this. I'm just gonna, this is 100 meters tall, and I'm throwing this at, and I'm shooting something at 30 meters per second. That's about 100 feet per second. That's not very fast. All right, 100 feet per second. See my rifles? I have a rifle that can go 3,000 feet per second. Okay. Oh, that's not one of my more powerful ones. That's one of my mid-level. All right. But that's another time to talk about, because we're going to talk about how do you compensate, like if you're hunting or whatever. Hunters, any hunters in here? Hunters, hunter. You don't hunt? You don't hunt, Emma? You should. Does your dad hunt?
Yeah, he does sometimes.
I used to a long time ago. It's kind of hard to find people with property and whatnot. So.
No, the Tabors, they own a tree lot, and so he gets rid of the deer sometimes. With
Yeah,
the Lassie, but
that's a good
pretty
thing.
much
You get
all
tired of
it
those. Yeah, because we have coyote. Where I live, I have a coyote, and I have a rifle that I keep in the garage just for that, because I got confronted with a coyote and he didn't want to run from me. So, and they're and the
Just
coyotes,
get a dog.
huh?
Just get a dog.
And they'll kill the dog.
Oh.
My
Coyotes.
dog would kill a coyote. What are you talking about?
If you have several coyotes, they'll attack your dog.
Yeah, if it's a
Yeah.
pack of coyotes.
Pack of them. So
I
I
like he says, I
can.
lived on a farm for my whole life, and my dog kept all the coyotes off our property forever.
You can't. Yeah, but that's not always the case. If they get in a pack, if they think in a human being, if they think they can take you, they will. Now, like I said, one of them, because I had one that confronted me and I couldn't get it to leave. I flailed and everything else, and it just stared at me. And I was actually scared because I didn't know what it was. It was huge. It was big. And like I said, they will take what they think they can take you. They will, especially if they're a pack. But follow this here. So this is not shooting straight up or down. This is shooting horizontally. So here's what we do. We have X direction and Y direction. We need to write down information that we know in the X direction. So let's start with the X direction. By the way, what equation dictates the X direction? It doesn't do what? Speed up, right? In the X direction, it's what? Constant. So, do I use the first three equations on that? What? No. D equals RT is the only thing you can use on that, all right? D equals RT is the only thing you can use. So let's write down, what do we know in the X direction? I know what. And I put D equals RT, you can do D equals VT if you want. So rate is 30 meters per second. I know nothing else. Oh, I don't even know what I'm looking for. Let's do this. Let's find out dx, and let's find out the time in the air. Dx is the x direction. How far did it go? All right, so, You okay? Okay. So, well, we don't have any more in the x direction, so we're looking for dx. So if I'm going to find dx, I need to find what? If I'm looking for d, and I have r, I need to find t. Now, guys, Variables don't pass from x to y. You got to keep them separate. All right? Except there's one variable that transcends both dimensions, and it's what? Time. So, what do we know in the y direction? Well, we're looking for time. Let's try to find time. What else do we know? What's the displacement? Be careful.
-100.
Negative 100 meters. What else do I know? Gravity is what? Negative 9.8 meters per second squared. What else do I know?
Initial velocity.
Oh my gosh, initial velocity is what? 0. So is there enough information to solve for time? Let's go for it. On the third equation, we have negative 100 is equal to initial velocity 0. Oh, that's nice. 1/2 times negative 9.8 times t squared. And if you get a negative t, what does that mean? You messed up.
I mean, you kind of have to.
What?
You just have to discon.
You better go back and rework,
No, I'm
relook
saying-
at it.
Oh,
When you
yeah.
square root.
It's plus or minus.
Oh, well, yeah, you're gonna run into
wrong
problems.
if you don't.
135.
Couldn't even
See,
get
but
an answer.
basically it doesn't
What's that?
So you're actually doing it wrong if you don't get one negative. You just have to.
Oh, no, come on, I'm not, okay. All right, don't listen to him, he's being a smart aleck, but he's right. All right, but my point is, if you get, yeah, you end up getting a t squared is equal to negative number, you got problems. What do you get for time? Obviously, we don't need the negative time, but it's what?
4.5.
4.5. So, we found our time to be 4.5 seconds. So what else? What else are we doing here?
Just plug and check.
Plug and chug equals RT. What'd you guys get for the distance in dx? 135.5 meters per meters?
Yeah.
Yeah. All right. You guys with me here?
Meter.
All right. Now, moving right along, let's make up a different type of problem. Follow with me here. I like this one. Because this is really kind of this is a good one here. I kick a football. This is at 30, huh?
That was the same.
So let's see.
Oh, sorry. 20 meters per second. This is 20 meters per second and 30 degrees. Here's what I want to know. All right, now folks, here's the cool part. We're actually taking previous ideas. No, did we talk about motion in the x direction in past? Yes. Have we talked about motion in the y direction in the past? Now we're just merging them, all right? If you actually get today, you'll get the gist of the chapter. So follow what I'm doing here. Here's what I want to do. I want to find the time in the air. How high, total horizontal distance. Let me make sure that's dx. All right? All right. Y'all got that down? How we doing here? All right, now, what do we do? I'm going to tell you guys, when you see this 20 meters per second at an angle, do you remember, we're talking about a vector here? How did we mess with vectors? What did we have to do? Do you remember vectors, how we add them together? What was the first step in all of them? You had to what? You had to break them down into components. Right, exactly. So, here's what we're doing. What we want to do is, we need to break this down into an x component. Let's break this down into a y component. And we need to do a shortcut. First of all, since we're given 30 degrees and the hypotenuse, we want to find the adjacent. We want to find the opposite. in this particular case, here's what I do. 20 cosine 30, this is 20 sine 30. And I want you to do that right now. 20 cosine 30, do that on the calculator. All right, so what do you get for 20 cosine 30? What do you get for the horizontal? 20 cosine 30.
Yeah, it is. You know there's an even shorter shortcut.
I know, it's 30 degrees. So what is,
Yeah.
what is the horizontal component?
30.3.
What is it?
17.3.
17.3? 17.3. What is the vertical?
10.
10 meters per second. Now here's the catch, folks. You no longer need that anymore. Does not play a part because everything now worked off of. All right? So let me just say this. You got to keep everything X direction separate from your Y direction, just like we did on our vectors. All right, so here's what we're going to do. We're going to write down what is our X direction, what is our Y direction. All right? So here's the deal. Let's write down. We want to do this. Let's find out what's the total time in the air. Well, what do we know that's in the Y direction? Well, I know the X direction. The rate is 17.3 meters per second. What's the Y direction? What do we know? The initial velocity is what? 10 meters per second. I'll even help you some more. The acceleration is negative 9.8 meters per second squared. We want to find the total time up there. Here's the deal. I want you to catch something. We want to visualize something. Where's my ball? Where's my balls? My ball over here. All right. So let's suppose, I want you to think about perception. What do you see? We're at the end zone. Here's the deal. Ben, stand up there, go to the other side. I'm gonna throw this ball. All right, don't worry, I'm just gonna throw it. What did you see from your side? I want you to get into physics mode. Let's think physics. Physics. Put everything aside. Don't think about your boyfriend, your girlfriend, or well, what you're eating for lunch, or the great food we're having today at school food lunch. Stay there. What did you see? What did you see? You saw a parabola. All right? Now, if you are standing behind me, and I did that same thing, and you have no depth perception. Listen to what I'm saying here. You know what I mean by no depth perception? And I did this again. And you see the parabola. You're behind me. You're in the end zone. And you have no depth perception. Means you can't see depth. What do you see? Explain to me what you see. What do you see? You see it what?
Down.
You see it going up
I'm going down.
and then going down. Have we ever seen that? I mean, where's that? Have we done that before? Throwing something up and it coming down? Have we talked about problems like that? Throwing up. So here's what you see. Stay there. So I basically, here's what you see. Up and down, right? You're in a blimp. See, this game is huge. This Friday. Goodyear blimps flying over. Okay? Big game. All right, homecoming, so the blimp is flying over. We do the same thing. A blimp is looking down. No depth perception. What do they observe from that? So again, we're talking about frame of reference. Your frame of reference, you see a parabola. This person over here sees what? A ball going straight up, straight down. What does a person in the blimp? What is their perception? They just see something, what? Start, describe the motion. Constant motion. All right, thank you. Everybody catching that. So what we're trying to do is, in the y direction, again, think physics, guys, get in physics mode here. So our rate, so we know it's constant velocity this way, and we're looking down, or constant velocity this way if you're looking down, and if you're behind, you see it in the y direction, you see it going up. What you're doing is, you're seeing the x and y component. All right? Your frame of reference, you see the x and y, you see the curve. You see what? Constant velocity this way with what? Variable velocity that way. But the person behind you, they don't see constant velocity, they see variable. Up, stop, and then increasing going down. Person from the top, they see what? Constant velocity. But you see everything. Does that make sense? So here's the deal. The initial velocity is 10, acceleration is negative 9.8. What's the final velocity? We said there's a myriad, so we're just really wanting to find the total time. So what I could do is what? Final velocity is 0, and then find time. So when I solve this, which equation? So what do you get for time? Everybody get 1 second for time? Is that my answer? Only thing I found was what?
Half of.
I've only found it right here. Correct? Does that make sense? I've only found it there. So what do you have to do? Double it. So our total time, t sub t, is equal to 2 seconds. How high did it go? Which equation for that? Second equation, I'm sorry,
Second and third.
first equation, that'd be easier. No, I'm sorry, wait, how high? I'm sorry, second equation. 0 is equal to what? 10 squared plus 2 times negative 9.8 times d. So what do I get for d? How high did it go? How high did it go? You make it 5.1? Does that sound right? So 5.1. Now I need to know how far did it go horizontally? D is equal to rate times time. D equals RT. First of all, what do we say that transcends both dimensions? Time. It's the only thing that does. So I know my total time in the air is 2. See, here's what happens. If you only do 1 second, you've just found the distance halfway. 2 seconds. So what, 2 times D equals RT? 34.6 meters per second? Yeah. Okay. Now, I'm not going to give your book assignment. I'm going to give you your handout first. Let you start. Not going to make it due tomorrow. How do we feel on this? Do we feel? I'm not saying you have it down perfect, because we're going to start. We're going to start some more tomorrow. We're going to do another one tomorrow. So take one and pass it. Take one. I want you to try to get 1 or 2 done before you leave. It is not due tomorrow if everybody like busts their tail and works. Good stuff. All right, and the video camera's still going. Hit that button, thank you.